Can you see my screen? Azanzi, can you see my screen?
I can see your screen.
Okay. Should we start now?
You can start.
Okay, perfect. So very good morning to all. Today we are here to represent our master class about the Open Research Knowledge Graph by Allard, Oelen, Sanju Tiwari, and Azanzi Jimeokong. So these are the basic outlines of our topic. So first, part one will be take care by Allard Oelen about the ORKG introduction. Part two will be take care by me, Sanju Tiwari, about the workflow methodology, how to prepare how to work with Open Research Knowledge Graph, ORKG contributions, and some hands-on exercises of ORKG. And the last part three will be taken care by Azanzi Jimeokong, a framework for organizing NACI research contributions by Azanzi. So I request to Allard Oelen, please take over your session. And I am stopping sharing from my side, so you can share from your side. Thank you.
Yes, thank you. Exactly. So then I will share my screen.
Yeah.
I think my screen should be visible now. Is that correct? So everything looks good. I cannot see a chat actually. So if somebody can tell me.
My screen is visible. It's okay.
Perfect.
Okay, great.
Please
Thank
go
you.
ahead.
Thank you. So indeed, I will start with a brief introduction into the Open Research Knowledge Graph. So my name is Allard Oelen. I'm a postdoctoral researcher at TIB in Hanover, Germany. And TIB is the officially called the Leibniz Information Center for Science and Technology. And we are a technical information library for Germany. So I will indeed start with really a broad and high-level introduction of the ORKG. And then first I try to answer the question, why do we need structured scholarly knowledge? And actually, what do we even mean with structured scholarly knowledge? And then afterwards, we can have a closer look at something called ORKG content types. And that is really how we can use the building blocks of the ORKG to create this structured knowledge. So yeah, let's first have a look at scholarly communication and what exactly is scholarly communication. So as we all know, scholarly knowledge is mostly communicated in a so-called narrative or document-based form. So if we have a paper, we have sections in there with sentences where we try to communicate the knowledge. So we create an introduction, related work, and so on. And we do all this to communicate our knowledge to an audience, and mostly to humans. What this means is that we are really focusing on humans and we are forgetting about machine actionability and machine readability, meaning that although humans can understand the content quite well, machines cannot. So it's quite hard for machines to for example, parse the contents, but also to really understand this content. And what does that mean? That means that if we are looking for specific information, in this example, we are looking for something called author name disambiguation. So we want to find papers that basically have this as a research topic. And we want those papers to use graph embeddings. So if we use Google Scholar to look for author disambiguation using the graph embeddings, you can see we have over 18,000 results. Of course, those results are not all relevant. Even most of those results aren't relevant. And one of the reasons is because we have this structured document-based form. So what we're trying to do with the Open Research Knowledge Graph is we're trying to transform those documents into structured knowledge or into graph structures. So first, let's have a look at why we have this format or what this format actually means. So we can see that the paper or journal published in the 17th century or in the 19th century is still, let's call it remarkably similar to papers we have nowadays. So it's still the same form, only of course now they are digital, which already improves things a lot. We don't have to go to the library anymore to find this, but still it's really cumbersome and we are not really using the new technologies to make these articles more findable and especially to make the knowledge within the articles more findable. So if instead we are using knowledge graphs to represent this structured knowledge instead of the article, it becomes really a lot easier to retrieve information. So here we have an example. So we have an article and you can see there is some structured data attached to it. So we have a title, a DOI, a list of authors, and we have an approach and a research problem. So this is a very high level, simple example, but we can already now distinguish between the metadata and the actual knowledge or so-called contribution data. So for the metadata part, this is something that has been handled already quite well by existing initiatives and existing systems. So for example, Google Scholar makes it quite easy to browse the metadata and to, for example, select articles based on a specific date. Even better organized is maybe Microsoft Academic Graph, so the former system from Microsoft, or Semantic Scholar is also quite heavily focused on the metadata. So we can say metadata for scholarly articles is being addressed and that's being done quite well. But what hasn't been addressed so much is really this contribution data here on top. So the actual knowledge within the paper. So if we think of our previous example we had, where I want to find those papers about author name disambiguation using graph embeddings, if all these papers were instead described in a structured way, then finding those papers would be a lot easier. It would be literally a simple search query where we say, okay, give me everything that has research problem, author name disambiguation, and approach graph embeddings. And that is exactly what the ORKG is trying to do. So here you can see we have the query to find those articles, and we have our outputting or output list of articles. So this is the main goal of the ORKG, to provide those structured supplements to scholarly articles. Now you understand why we need structured scholarly knowledge and what we're trying to improve, and also what we're trying to do in the end. We can have a closer look at the ORKG content types. So what can you actually do within the ORKG as a system to create structured scholarly knowledge? And then later on, also Azanzi and Sanju will present and will show you how you can actually do this in a real life example. So something called ORKG content type, we consider them as specific artifacts in the graph with a special function. So we are collecting papers in the graph, also metadata because it's necessary. So we also have the authors and so on. But 5 types we are really focusing on are listed here. So we have lists, papers, comparisons, visualizations, and reviews. So looking at the list, an ORKG list is really a list of papers and their metadata. So there is not that much structured knowledge going on yet, but it's at least grouping similar papers with similar topics in the same list. And here you can see an example. So this is a paper, if I'm correct, from COVID-19. So it is related to COVID-19 research. And you can see it has the metadata, it has the research fields, virology, and it's listed among other entries in this list that also have the same research fields. So what we can do now, since we have this list of papers, we can select those papers, and for each of those papers, we can start describing them in a structured way. So that's the next step, where we then end up with an ORKG paper. So if you compare this little subgraph to this one, so you can see that the metadata still is there, but we are extending this and we are adding contribution data to it. So with contribution, it's a term in the ORKG, but what we really mean with this is why the paper was written. So what does it contribute to science or to the scientific knowledge we have? And that's why it's called a contribution. And we can see contribution has an approach. It has an R0 estimate in this case, and it has a location. So we can describe these contributions for all the papers we had in our list. And now I'm showing you a very simple example, but of course it's possible to create much more complex examples, which is normally not a goal, but sometimes needed to describe complex data structures. And you can also do this with existing ontologies. Another feature we have there are so-called templates. So templates provide the structure of the graph already, but without the values. So in case you are familiar with Shekel, it's really related to Shekel shapes, where we provide the shape of how the paper can be described, but of course we don't provide the actual values. So if we would create a template out of this graph here, it would mean there is a contribution and the properties approach the R0 estimate in the location, but not the actual values around here. And also the templates can be more complex structures that are, for example, containing nested data. If we now have our list of papers that are all described in a structured way, we can put them into our next artifact called comparisons. And this is one of the key elements of the open research knowledge graph. So when we have papers that address, in this case, the same research problem, which is the determination of the R0 number for COVID-19, we can plot all those different articles in this tabular form. So here, in this case, we have an example of 3 papers, and we can make that a bit bigger, and we got 4 papers here. So you can see they all address the same research problem, and we can then compare their R0 estimates here. And we can see for which location what R0 number has been measured, including a confidence interval. So ORKG comparisons really have the focus on customizability and reusability. So as a user, as you are generating those overviews of related work, you can quite freely design those comparisons and use them in your own work. So that includes adding and removing properties from the papers that are listed. You can sort the properties, you can transpose the table, and so on. And of course, very important, it's possible to also add contributions to the table. So especially this is useful if new work becomes available. It's possible to update a comparison. So they are dynamic in that sense, and new work can be added. Also, the reusability is an important aspect. And we make that possible by assigning DOIs to the comparisons. So comparisons can be published, meaning that we take a whole snapshot of a comparison, assign a DOI to it, and with this DOI, of course, you can always see the same comparison. So the comparison is persistent. If then new work becomes available, it's possible to update the comparison and assign a new DOI to the artifact. Also, it's possible to export it in LaTeX, CSV, PDF, which is then specifically for humans again, or RDF, which is very suitable for machine readability. So we're really trying to make this a dynamic overview of literature that can be maintained by a community. So it's open for everybody to add and edit the comparisons, just to make sure there is a really state-of-the-art overview for specific research problems. So if we then move on to the next content type here, that is ORKG visualizations. And that is especially useful if we have a comparison that contains a lot of numeric data. So in our COVID-19 example, we can see these different values. This comparison looks a bit different. So here you can see the confidence interval is split into two different rows. But of course, it might help to have a visual representation here other than a table, but for example, a scatter plot to show and to make comparing these numbers easier. So the ORKG visualizations have the inputs or have comparisons as an input, and the output is a different way of visualizing that, especially suitable for numeric types. Then finally, the ORKG reviews. So an ORKG review takes in all of the previously discussed content. So it takes in papers, comparisons, visualizations, and it puts them in a dynamic literature review. So here you have a small example of such a review. We can see there is a comparison, and normally comparisons are really the centerpiece of ORKG reviews. So they're the most important content type there. And it's possible to add some natural text, and that is really specific to the ORKG reviews. So that can be added, and that is not already part of the graph. And these small pieces of text that are being added in, they are really to increase the human readability, as the comparisons might need some more context or explanation. The review content function here is really suitable to do that. So we can also add additional types to the ORKG reviews. So I talked to you about papers right now, but we also have many other content types in the graph. So we also describe software in a structured manner. We describe dataset in a structured manner. And it might be suitable, or it might be a good idea if you want to compare several pieces of software, maybe how they develop over time, or datasets, to put them in a review and to also alter this. Just like the comparisons, also the reviews are dynamic, meaning that if new work becomes available, they can be added to an ORKG review. And this is really suitable for fields that are developing rapidly. So that's also why I took the COVID-19 example here as a use case. So during the pandemic, many papers came out to report on the R0 estimates. Of course, if you publish then a review article, it is almost outdated as soon as it's published. So that's why a more dynamic way of publishing review articles is really suitable for this kind of research problem. So that's it from my side. So I really gave a very brief introduction in the ORKG, in what we're trying to achieve, what do we consider structured knowledge, and how should we generate it, and a bit about the content types of the ORKG, so the different items you can create in the graph. And now I think we're moving on to Sanju, who will show you more use case related examples in how to interact with the graph. Thank you.
Okay, thank you, Allard. So let me share the screen first. Can you see my screen?
Yeah, looks good.
Yes.
Okay. So I am Sanju Tiwari, ORKG curator at ORKG Hannover, Germany, and senior researcher at UAT Mexico. So I'm going to explain about ORKG contributions and methodology. As Allard has already covered about the introduction basics of Open Research Knowledge Graph very nicely. So here you can see why knowledge graph. So first of all, I would like to explain that the basic introduction about the why knowledge graphs, that why this is very popular question sometimes asked by community. So here is the machine actionable First of all, ORKG makes the machine actionable data because the paper, the contribution has linked with each other, and it helped to finding and linking of the research contribution toward a specific problem. So as you can see here that it is a graph like structure, and every entity are connected here. It is also helping to provide the answer of knowledge natural language questions and explore the knowledge in entirely new ways. So here are some points that will justify why we need ORKG. Basically, as we know that the published scholarly knowledge is unstructured and it is published in PDF. So it is sometimes it is very difficult to extract the required information quickly, and it is complex task to review the existing literature, or basically as we know that search is keyword based. For example, you can see if you are searching a COVID-19 reproductive, there are so many results, lakhs results. So it is very complex to find the required relevant information from this result, because it is not machine actionable and it does not meet the fair data principles, and the whole process is manual and hence the time consuming. We are searching manually, and then it is required to read them and then extract the relevant time. So to replace this thing, to replace this process, ORKG is a perfect solution to do this. What are the issues in current approaches? There are so many approaches are available, but still how ORKG is better, that there are some issues are found, like these are static in nature, delay, coverage is also an issue, lacking collaboration, lacking of machine assistance is the main motive of the ORKG to extract the knowledge from the contribution from the literature. So and missing overarching systematic semantic representations, that is the open research knowledge graph ORKG provide a semantic representation that is not found in other approaches. So here we can see that every year 2.5 million new publications publishing per year, and it is very difficult to find the relevant contribution from this publication flood. And basically sometimes it is giving the loss of knowledge, answering because answering question answering is not easy. It is just like to find a needle in the haystack. So it needs to digitalize the knowledge rather than document. For example, you can see here that this is the search in the old Google. You can see it when we are getting only the HTML document rather than the metadata information. But in the new version, current version, you can see that when you are searching some, you are getting extra information, the some metadata information that is giving about the, if you are searching a product, so you are getting the price, color and picture. That was not possible here, so it need more time to search, and here you can save your time to find the relevant one. So this is the reason that we need the open research knowledge graph to find the relevant information, to find the digitalized knowledge from the literature. So here you can see that the example I have taken from there. This is already explained by the Allard. So here you can see that this is a literature and this is a paper, a practical guide on this. So you can see that how it is represented with knowledge. So it is represented as a graph, that this is a title of paper, he is the author of this, and this is the address and sub problem of, there are so many properties that are connecting with different attributes here. So major objectives of the ORKG, to provide the overview over the state of the art for a specific research problem. In the next slide, I am going to explain how to generalize a specific problem and how to make a simple simple hands-on exercise on the ORKG. So, and the second objective, foster collaboration that is findable, accessible, interoperable and reusable to make research fair. The next objective, focus on scientific content rather than documents and metadata. The objective that I have already explained, that digitize knowledge rather than document. So it is focusing on the scientific content inside the data, inside the inside the content, and tackle interdisciplinary challenges such as climate change, research, disease prevention, etc. So it is, ORKG is not only for the computer science, it is for interdisciplinary streams. And so these are the major research papers that are already published with on the ORKG. So anyone can get access from here. These are some ORKG contribution that we have already done, and these are the title is the research problem, like analyzing COVID-19 ontologies, current status of COVID-19 ontologies, and one of the existing smart building domain knowledge, ontologies. So we have analyzed the smart building domain ontologies in this comparison, and it has 15 ontologies, and one and so on. There are some other also research problems in during my curation grant program, and you can see the graph view. ORKG also provide the graph view, but like here you can see that this is the contribution, and contribution has research problem that exploring smart building domain ontology, and it is about contribution is think home ontology and has metadata information. This is the metadata information that is connected with it, and this contribution is about think home ontology because there are so many ontology are connected with this. So we have taken one that is think home ontology, and it has several properties and their values. So you can see that how it is showing a graph view to understand a contribution, that without reading the whole paper about this contribution, you can know about this paper, that who wrote this paper, what is the metadata information, and what about this paper has been presented. So you can know by this graph view or by this contribution comparison window. And this smart building ORKG contribution has been used in sphere project, that they have used it to analyze these 15 ontologies, and they have the whole ORKG existing smart building domain ontologies comparison that they have used in this white paper. So now I would like to go about the methodology, basically how to start work. So maybe some of you, if you are beginner, so it is very useful to understand that what to do, how to start and how to do. So there are 4 steps. Like first of all, we need to find a research problem, a general topic from any stream of science. It's not necessary to take the only computer science. So first of all, we need to find a research problem, like I have shown last exploring smart building domain ontology. So here you can see that acquiring that the second step is acquiring the research papers. So on this topic, like smart building domain ontology is the topic, then you need to collect the research paper, the related research paper on this topic, collecting most related articles based on a common research problem. So this is the second step. And in the third step, acquiring knowledge, collecting machine actionable data from research articles. So here you can see that how to convert in knowledge. Now you have to extract the knowledge from the papers, and you have to generate relevant, you have to extract the relevant information and then transform into comparison reviews. So it need to organize the knowledge in fair principle. So I would like to share here that how I have. So first of all, for example, it is already done. So I am showing here the research problem was ontology learning tool. So I have collected several papers related with the ontology learning tools. So you can see here that SOAT, Svetlan, Termini, Cracktole, extracting concept map with clouds and automatically. These are all the ontology learning tools. These all papers are related with the ontology learning tools. So this was the first step, the research problem. This is the second step, acquiring research article. And then Then you can see how acquiring knowledge from papers in an Excel sheet. You can see that ontology learning tools is in all names, goal and scope, learning techniques, method followed, type of sources, evaluation metrics, output, and all the properties I have stored here in the Excel sheet. And then organizing this knowledge in the ORKG. So you can see here, from papers to knowledge, you can see that this knowledge how transform into the ORKG. So here you can see this comparison is already available in this link, and these all papers are there. And you can see that has research problem analyzing ontology learning tools is about ontology learning tool. Ontology learning tool has name, ASIAM, goal and scope, input type, learning technique, and so on. So the image only showing only 4 contribution, but there are 15 contribution in this comparison. So I will show you on the ORKG window. Let's finish the first. So yes, sorry. So now the question is who can use. So it can be used, everyone can anyone can be used, can add, can edit, can reuse the published contribution, and like librarians, information scientists, domain experts, users. And before using it, you need to have an account in the ORKG. Major queries that are generally raised by the community. So how it will helpful to all stream of science. So many times I have received this type of question. I am not an expert of knowledge graph, so how can I work with ORKG? So you can see here that it is not only for knowledge graphs or only for computer science, but it is for all kind of streams. Like here you can say arts and humanities, engineering, life sciences, physical sciences and mathematics, social and behavioral sciences. So it is because literature is available for all kind of streams, and you can model their anyone can model their knowledge in this ORKG. Here you can see some of the comparisons are available on different streams, like conductivity of nanocomposite electrolyte based on alumina, mechanical properties of tough hydrogels, mechanical properties of unusual hydrogels, mechanical properties of double network hydrogel, kinetic human. They are not generally, I am reading this because they are not related with the only for the computer science. They are other streams of science. So you can see so many work are there. These are some links of curation grant program that already had done first ORKG curation grant, second curation grant program. Now the time is the now this slide I'm going to explain about the some hands-on series exercises. So first of all, sign in statements, papers, visualization, reviews, resources, properties, classes, comparison, and export citation. So as I told, to use open research knowledge graph, first of all you need to sign in the ORKG. You need to have an account and you need to sign in to use the open research knowledge graph. And this is the export citation. So let me come on the ORKG window, so it will be more better to explain on there. So this is the window, and I am already logged in here. So you can see that this is, and I have created an Excel sheet. You can see that there are some language models. You can see that GPT-3, PALM, Bloom, and research problem is analyzing foundation models, is about foundation models. And I tried to make it. So quickly, I would like to show you. So here you can see add new option, and here you can include your comparisons, papers, and others. And these are the some menus. View. Here you can see already existing comparisons, papers, visualization, reviews, list, benchmarks, observatories, resources, properties, classes, and tools. There are some tools, and there are about help center is also available here, and other statistics and GitLab you can access from here. So here you can see that I have included two papers, that language models are few short learner, contribution 1, and this is the contribution 2. So contribution 2 is PALM, scaling language modeling with pathways. And now I want to add, if you need to add one more contribution here to compare three contribution. So first of all, I would like to add a paper, because so that we can see that how to add paper. The paper title is this. So first of all, we need to find this title manually. You can, by if you have DOI, you can go by DOI, but I am doing here, it is manually, and it is not available, maybe it is not published. So you can find the data just to metadata information. It is in ORKG. So I'm just taking one author name to just make the entry, and here add author. So it depends on you. You can include all. So this is the author name, publication date November 2023. Sorry, 2022 something. Maybe it is not. So published in, as you can see, it is in archive. And URL, you can give this URL here as a metadata information. So here you can see, you can give this thing, right? And next step, so it is already available here. Okay, I am continuing it. The recent the field is, and now add property. So this is how to add property. So you can see what are the properties. Has research problem, is about. These are the major properties, and they are further categorized. If you will click here, foundation models has further properties. That foundation model has name, has model type, has trained parameter. So you need to specify these properties first. That has research problem, this is a property. You can reuse the property, and here you can write the same data. This is, you can see that this is resource, because you can link further it, you can categorize. If you will use text, you cannot categorize, then you cannot connect with another entity. So it is always suggest, when you know that you will connect with another entity, so you need to make it resource. So the next is about. So is about foundation models, and I need to create a new one as a resource. So here you can click it, and then you can further add, like has name, you can see what are the further properties. So has name, and here its name is Bloom. Has name is already available, yeah, so we can reuse it, and its name is Bloom. I'm not putting other just a minute. Model type, yeah, one more I am putting it, so you can see how to model type. So maybe this is available, so it is decoder only. So I'm take it reuse. This is the using already existing entities, existing resources is always suggested. So this is done here. Now you need to finish, and now we need to add this paper in the comparison box. Here you can see that this is a comparison box, and now you can click add contribution. Two are already there, and I am including the third one. So I am taking this one. And you can see that these properties that I have already included there, they are here. And now you can see the view comparison. Just an example. It is not published yet, but you can see that this language model 2020 is talk about GPT-3. It is a type of decoder only, and it trained 175 billion parameters. And about the PAM, you can see this is also, and these are the trained parameters. I did not put this value, although you can put it value before publication or after publication. Anytime you can change the value. So then you can go action, and here you can go for publications. So for publish, you can publish it. I'm not going to publish it because I have to include it more. But you, if you have done you have 3 to 4 contributions, so you can publish it and you can get the link. I will show you title, description, research field, creators, assign DOI, everything you can put here, and then you can publish it. So here i I also want to show you that how to export the citation. If you want to cite it, you can see this is the latex. Sorry, you need to go on the action window, and then you need to click at export as latex, and here you can see the bibtex references. So from here, when your comparison will be published, you can get your published comparisons citation here. So this was the way to uh, sorry, to publish a comparison and include the contribution. In that way you can include other contributions also. And now I would like to go on the ORKG. Sorry. So I want to show you here. You can see top contributors on the home page, and latest last updates, like I have added a contribution bloom, so you can see on the home page. And you can see that there are comparisons, visualization, papers you can go through, and you can access from here, from the window. I also want to show you the some second. Here in this page, you can get the curation grant program that are already done by several curators on different theme. And there are several videos are available here. It is taking some bit time, so no problem. Let it do. And, let me come on the presentation. So this was the properties, classes, comparison, exports, addition, and hands-on exercises, statement, everything that I have shown in the previous in the running mode. So this was ORKG team meet in last June 2022 during my dad visit. So we have I have presented one comparison in this team with Professor Soren. And so let me check if it is open. Yeah. So this is the second curation grant program, and anyone can go here and can get that. Azanzi is the first one. That there are some videos also available. So many comparisons are available on food ontologies, construction description, and some other topic also. There are number of curators have done so many work with their videos also, so it is very easy to understand. So I think I need to stop it now from here, and I need to hand over to Azanzi for his presentation. So this is my contact, and if you have any queries, you can contact here. Thank you so much. So, Azanzi, can you please take over? I am stopping to share from my side.
Okay. Let me share my screen first. Sharing the screen. Okay. Window. Can you see my screen?
Yeah.
Okay. Thank you. Slideshow. Okay. Hi, everyone. I'm Azanzi Jimeokong. I am assistant professor from the University of Yaoundé 1. I'm using ORKG since 2 years to organize my research. Then I'm going to present you a feedback on how to use ORKG to organize your research. In general, I'm taking the case of neural symbolic research contribution. Then from people who are new to the neural symbolic, artificial intelligence can be viewed as two parts. We have the connectionist model, in which we have machine learning and deep learning models that are trained on large quantity of data, and also have symbolic representation, in which symbolic representation AI, in which the world is seen as symbols with properties and connected to each other. The machine learning and deep learning have attained state of the art to solve many research problems, and they are used to solve real-world problems in healthcare, finance, etc. But the problem with machine learning and deep learning, sometimes we want to know why we are getting this prediction, and in many cases, the information that are provided are difficult to connect. For example, if I take the example of a project in which I'm working currently on food information engineering, if we are using neural network, for example, to identify some food and the elements that are inside the food, and we are using food knowledge, food composition knowledge graph, in order to determine which are the components, which are the nutrients that are inside this food. And we are also using a neural network to collect data from scientific paper, to collect food composition tables, and we are using knowledge graph, food composition knowledge graphs, to organize and structure this knowledge graph, and that is neural symbolic. It aims to build a rich computational AI models, system and application, and it aims to combine the robust machine learning models with symbolic knowledge in order to provide more powerful system to train with. The main advantage is that they can be trained with less data, they are robust to noise, and so on and so forth. In our case, we are combining these two components in order to get information and then to infer new information given to the information that we got from the connectionist model. The neural symbolic system is quite a new domain, but if you see the number of papers that are published since 10 years, there are a lot of papers, more than hundreds of people. And the increase of the scientific content of the neural symbolic domain can pose many difficulties to new researchers who want to start from somewhere. The common question that I see in the Slack channel, in which I share with researchers, is from where should I start? What are the main concepts? And for experienced researchers, it can be very difficult to get insight from paper published by fellow researchers. For example, after a conference, let's say 20 to 40 papers can be published, and to get insight from this paper, it can be very difficult. Then we are proposing a framework. We are proposing a framework composed of ORKG templates and comparison table that can be used by a community of neural symbolic researchers to organize their research paper, to organize the research in the domain of neural symbolic, and to get absolute beginners with the main concept, with the research problem, the methodology, the method, the tools, etc. But to also to help experienced researchers to discover very fastly new insights. For example, if an author can describe his paper using the templates and add in a comparison table, it can help new experienced researchers to rapidly get insight from the new papers that is just published. Then to build this framework, we identified some questions from Twitter and some on Slack channel. Many people, many master students and sometimes PhD students are asking from where to start. Then we provided from where to start. We are providing a template to describe the main concept. For each paper, we are also providing a template to describe the research contribution that are in this template. We found also that many papers are using some data sets to describing the data set that they are using to train their models. And we found it important also to identify which are the connectionist models that are used and which are the symbolic models that are used by researchers and the NESI model that are used, but also to describe the different reasoning engines that are considered. The main feature of this of this framework is first, the semantic description of the NESI paper. The goal is to allow the researchers to organize, to describe the semantic, to semantically describe their research paper so that they can be used to organize the NESI research paper, or the NESI research paper, and to compare them. Then the goal here is to gather around this template researchers on neural symbolic so that collaboratively they can work and build a body of knowledge of their domain in order to see with time how the domain have evolved, and as I said before, for new researchers to get insight fastly and for experienced researchers to get new insight from the work of others. Then the template is composed of, I said before, the framework is composed of templates and comparison table. The template is the first component of this framework, and the first template that I'm going to present is the NESI main concept. This template describes the main concept of the NESI domain and independently to the scientific papers. Then in many papers, the authors are going to present the main concept. For example, the abbreviation, I'll show you directly here. Then this template is composed of 10 properties, and I got this property from the research papers that I read on neural symbolic and from the questions that I saw in the Slack channel on Twitter. Then what is the purpose of neural symbolic? Then we provide here a neural symbolic purpose. This is a class which resembles the different purposes that are provided by authors about a neural symbolic. Then another question is the research field. In which research field the neural symbolic is applied? Then we reuse the research field class here because we thought it important to reuse some instances that are already published, that are already registered by other researchers. Then if I go back to the neural symbolic purpose and I show the different instances here, you'll see that this is one of the research purpose: provide a coherent, unifying view of logic and connection to contribute to the modeling and understanding of cognition and thereby behavior. Then that is one purpose that is registered in the system. Then if I go back here to the research field, you will see that neural symbolic is used in botany, in agronomy, in plant science, etc. Sorry, these are the different research fields that are already registered in the system. And I just have to search to choose amongst them which one I think which one the author of a paper is using in his research. Then I also have the different AI paradigm that is used: neural symbolic AI, neural connectionist models, symbolic models, etc. The research problem, the different problems that are presented by the authors, the evaluation matrix. Sometimes when you are working on a model, the question is, how should I evaluate it? Then I thought it important to put here a property evaluation metric to see the different metrics that are used to evaluate a neural symbolic, and also the keywords. It can help a lot a new researcher who is seeking for keywords for his paper. Then I found it also interesting to add the spelling, because I found if you see in the literature, you see neural symbolic, neurosymbolic learning, etc. And it can be confusing for a newcomer, and the abbreviation and the different process that the author are describing. Then this template is to describe the generic concept, the main concept, the very different from the contribution of the author. Then the second template that I'm presenting is the neural symbolic system. I call system, but it's to describe the different papers that are published, that the different neural symbolic papers. And we have the name, the system name, and we have the class neural symbolic system here, the purpose of the paper or the system, the AR paradigm that are described, that are used to solve the problem, the connectionist model that are considered, the symbolic model, the methodology, if they have provided, the method, the process, the application area. Then I'll show it after. Many systems are applied in different domains. For example, in retinopathy, the research problem, the configuration setting. In many cases, the authors are providing the configuration setting of their experimentation. Then we also have the configuration setting here, the data set that are used, the data sources from which the data set are coming from, the system feature, what are the different features of the system that are presented, the different problem that the author is addressing, the evaluation metric also, the description, the reasoning type, the different type of reasoning that are provided, that are used by the author, what's the role of the reasoning. Sometimes the authors want to generate a taxonomy, the ablation study. In many cases, the authors are using connectionist model, are using neural symbolic model, and after they are removing the symbolic part in order to see what's the impact of the symbolic aspect to the model. Then in many cases, they are also presenting the limit of existing system, mainly either connectionist model or symbolic models, and the limit of the system that is built, and the future work, and the output format. The output format can be taxonomy in the taxonomy, and the input format of the system, the link of the system, the evaluation, recall, precision, accuracy, etc. In many cases, they are also using external data sets to compare with the system they are building, the neural symbolic model, the computational evaluation, and the okay then. And the third template is about the neural symbolic data set. The idea here is to provide to the community with a benchmark of the different data sets that are used in the domain of neural symbolic. Then for now, we use two papers, one in the domain of recommendation and one in the domain of computer vision. And we use it to build this data set, which count 22 properties. We have the data set name. We can reuse some data sets that are already present in ORKG. We have the license. We have the type of the data set. Is it a knowledge graph? Is it a data set of image, of sound, etc.? We have the link of the data set. We have from which the data set is coming from, the different data sources. If it is the image data set, we have the image resolution. If the image was resized before being used in the system, the different label of the image, the splitting techniques. Generally, the authors can split the data set in order to train the model, to test the model, and to validate the model. The number of trained image, of trace image, and in case of recommendation system, the number of rating, the number of users, the number of entities, etc. Then we also have the connectionist AI model. Then for the connectionist AI model, we found it important also to compare the different connectionist models that are provided, that are presented by the authors, and how they are using this connectionist model, Then it's taking some time to open. Okay, then concerning the connectionist model, for now, we have the model name, in which case the model is used, the description of the model, the optimizer. We found that many connectionist model has a parameter called optimizer, the batch size, the learning rate, the dropout probability, the number of epochs, and if the model has early stopped. Then we also provided the symbolic AI model template. Then I will open the last one also. Then we also provided the symbolic AI, but for now, currently, we have the model name, the purpose, the description, the reasoning engine that is used, that can be used when you are using this symbolic AI model, and the logic type that is considered. Then if you go in the logic type class, you'll find the different logic, the current logic type that are already registered in the system. Then concerning the neural symbolic, we also have 5 properties. We have the model name, we have the purpose, the description, the different feature of the neural symbolic, and the logic type. Then concerning the logic type, for now, we have the real logic, we have the first order language, and we can have more when the domain will be populated with more data. Okay, then we also have the reasoning engine, but I want to present you one example of a paper that is used that the template was used to organize the research contribution. Okay, it's taking some time to open. Okay, then the paper is about explainable diabetic retinopathy classification based on neural symbolic learning, and it was published in international workshop on neural symbolic learning in 2021. Then I'll start with the main concept. The main concept, I also registered, and I can click on edit in order to show you. Then if I click there, you are going to see that this research contribution is built using neural symbolic main concept, the template that I presented before. Then we have the AI paradigm that they are presenting here is neural symbolic AI, the evaluation metric accuracy, the process, the generic process that they say, the authors say that generally neural symbolic system followed system segmentation network, generation of symbolic representation, learning of symbolic representation, the research problem, the keywords, the three keywords that they provided, the method that they used, the problem that they are addressing is the lack of explainability and the understanding decision-making process, the purpose of neural symbolic system in general, the research field, they are working in the domain of computer vision, the research problem, explainable artificial intelligence, and the spelling here is neural symbolic learning. Then if we move to the description, this is the second template that I presented. Then the template here is neural symbolic system. It's not the neural symbolic main concept has the first contribution. And then they are using the ablation study. They are removing the symbolic component in order to see the impact of the symbolic component to the system. Then the AI paradigm is neural symbolic. The application area is diabetic retinopathy, and it's the medical domain. I add the two because I wanted to present to have the information that the work is in the medical domain. We have the connectionist model. They are using several connectionist model either to experiment their work. The fully connected network, the network model, the ResNet 24, and the UNet. The data set, they are using the Indian diabetic retinopathy image data set. The evaluation, the proposed solution, the author says that the proposed solution exhibit promising result compared to the state of the art. The evaluation metric, they use the accuracy concerning the future work they presented here, the process that they use in their research, the research problem, the limit of existing, and the method. The output format here is taxonomy. At the end, they want to have a taxonomy of the problem that given to the image of an eye. Yeah. Okay. Then the problems here, the purpose of the system, etc. Then we can move to the last data set. They presented a certain number of data sets with the number of image, for example, the number of image that is in the data set, the text image, the trained image, the data set name, lesions, segmentation, read data set, the data set type, etc. And the different labels that they have in the data set, the image resolution, the resize the image, and the license of the data set. The data set is public. Then they provide also several other data sets that are here. Also, we have now they present the first connectionist model, and they are using to learn complex input data to generate higher level representation, and the model name is deep neural network. And we also have the connectionist SCN model, and we have the number of epochs that was used to train the model, the batch size, the dropout probability. Yes, the model have early stopped. The case in which they use the model, the learning rates, the model name, the fully connected network, and the optimizer. They use the Adam optimizer in there to train their model. Then we also have the ResNet 24, the fourth are the neural symbolic models. Then the method, this model is deep prologued, and they are combining end-to-end learning with reasoning, and the output of the neural network are applied to the input of prologue. Then they use also symbolic logical neural network. They used also logical neural network, and you have the case, the description of the use here, and the logical neural network. And if you want to know the template that was used to 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 organize, to create this contribution, you can just click here and you have the neural symbolic model here. What is interesting also is that you also have the rest of the properties here. Then you just have to, if you want to add more insight, if you have forgotten something and you want to come back and complete, you can just click here and complete. But what we are doing here is we are getting the information from the paper has the authors published it. Then we are not adding anything, we are not removing anything, even if we think it is important, because we want to provide the clear description of the system. Then this is another Nesi model. And now we can see here that they experiment their model with several models. For example, they use the ResNet and DenseNet, and they on the Indian diabetic retinopathy dataset and the evaluation metric, and they have the accuracy. The system has this accuracy, and the system name is AFSAV. Sorry. Then they use the simple symbol. They add the simple symbol to this model, then explainable DR with simple symbols, and they obtain this accuracy. And they extended the symbol, they add more symbols, and they obtain this accuracy. And as I said before, they are using the ablation study, and they found that adding symbolic representation to the system allow the system to have more to be more powerful. Then using this contribution, we can now build comparison tables. The first comparison table that I built, for now it is with 2 papers, but I'm planning to add more papers, or also if any authors are interested to document their domain with the template. If you have any difficulties, you can just email me. I'll contribute. I'll help you to organize your paper so that we can build a very big data set of NESI domain. Then I compare now the explainable retinopathy classification based on neural symbolic learning that I presented. These are the main concept, with the logic tensor network for top-end recommendation. This is another paper that I documented. And the AI paradigm here is neural symbolic. The evaluation metric you see here, it is ITCA and NDCG car, but here they use the accuracy. That's very important because it allows people to know that you can use accuracy or hit car or NDC car to evaluate your system. The different keywords we have here, the different problem. Here we have the call star problem in data and the data sparsity, the research field. Here we have the recommendation system, but here we have computer vision. The spelling here is neural symbolic and neural symbolic learning. The abbreviation, they provided the abbreviation here, but here they didn't. The process, they provided the process, they provided the research problem, the method, the purpose of the system, etc. Okay, then the second comparison table that I'm going to present is the benchmark. This benchmark comes from the 2 papers that I just presented. Okay, I'm going to open the third one, the connectionist model and the NESI model. Okay, the benchmark is composed of the explainable benchmark. Yes, this is the benchmark describing the different papers. Then we have 2 papers with the different contribution. And here, explainable diabetic retinopathy, we have the AI paradigm that they are using, the application area diabetic retinopathy. Here we have the product recommendation is different. And here we have the medical domain, the data set that they are using. Here they are using the mean reader dataset, the self-defined knowledge base, and they self-define a knowledge base in addition to the mean reader dataset that they presented in the paper. The evaluation, you have the evaluation here, the evaluation metric, we have the accuracy, the different limits of the existing system, the method, the problem, the purpose, the system feature, explainability here, the recommendation of top-end product to users. Then these people use ablation study, but these people didn't say anything. Then you didn't add anything because you don't know if they use or if they didn't use. Then the configuration setting, this is the configuration setting of the top-end recommendation system. They use a 6-core Intel, the core Intel i7, the Apple MacBook, etc. The connectionist model that these people provided, the future work, the limit of the system. The neural symbolic model that they use is logic tensor network. The first system just say that, okay, we add symbols, we provided symbols to our system, to our neural network, and we obtain a better evaluation. But these people use logic tensor network directly in their system. Then the output here is, for example, is taxonomy, etc. Okay, then if I move to the connectionist model, the connectionist model that I identify are the connectionist deep neural network, the connectionist fully connected network, and the ResNet 24. Then these are the three connectionist model. The number of epochs that was used to train the fully connected network was 20 here, the number of batch size, etc. And concerning the neural symbolic, we have the logic tensor network that was provided, the deep prologue, the symbolic, the logical neural network, and the logic network. Then that are the different neural symbolic systems that are provided, the NESI models. Then I'm going to finish this presentation with a hand-on session on the use of these templates to document your data. I found important to do it because at the end we can say that from which can I start? I can start with this paper, Visual Sudoku Puzzle Classification. This is a paper published by NESI Workshop. I'm going just to copy the title and I come back here. I'm going to search the paper in the system. Okay, I found the paper. I can click on the paper. Okay, in the paper, the paper didn't have information yet. Then I'm going to click on Edit. Now, I already document I already read the paper and identify some important aspect of this paper that can be interesting. Then I'm going to search for the neural symbolic main concept template. Let me write neural symbolic. Okay, I have neural symbolic main concept here. If I click on it, then I have the purpose here. What is the purpose of neural symbolic according to this author? The advantage of using classes as I presented in the paper and in the template is that it allows you to group several instances so that you can easily choose among the existing instances. But in our case, it is not the same. Then I'm going to type it, integrating the low-level representation over of deep learning neural network, deep neural network higher level symbolic reasoning. Then when I finish to type, I create directly on create, and this you create this resource has. Okay, I'll open this resource. Okay, I want to go to the resource. Where to go? Okay, if I go to the resource, we'll see that this resource is the instance of the neural symbolic purpose class. Then I have the purpose here, integrating low-level representation power of deep neural network with higher-level symbolic reasoning. Then I can continue with, I can go back and continue here with the research field. The research field is the gaming. Then The AI paradigm that they are using here is visual perception, and relational constraint AI. Then the research problem is the NESI benchmark dataset construction. In fact, the authors are saying that there is a lack of data sets that are focused on neural symbolic. Then they want to create a new neural symbolic research data set. Okay, concerning the different problems that we have, the authors highlighted that their lack of comprehensive NESI data set. Then they are spelling it has the keywords. I can just go back here and get the keywords. Then we have benchmark. And we have data set. We have neural symbolic integration. We have relational data. We have structured prediction. Okay, then the spelling, they are using neurosymbolic. Neurosymbolic. Then I can click on create. And the abbreviation, they add an abbreviation, and the abbreviation is NESI. We found NESI already registered in the system. Then I'm just going to click on create. Then I want to name my contribution. I want to add a name. I want to add that this is the main concept. Main concept. Then I can create the second contribution, which can be about the different data set that the authors presented in the paper. Then the author presented several Sudoku data sets. Then I can call it second data set. Then I'm going to use the dataset template. And I'm going to type neural symbolic. And I should choose neural symbolic dataset. Okay, then the dataset name is this is Sudoku dataset. License, they didn't. I didn't find the license. I didn't read the paper completely, but the number of images. Then I'm going to search for the number of images. Then I can use images like this. The number of images, and concerning the number of images, I want to. I'm going to use another template. I will show it. NB images. Then I'll create this resource. I'm going to go to this resource and to use another template that is already in the system, which allow to describe the quantity and the quantity value. I think this template. Okay, the quantity and the unit. Then here we have, they say that they have 70,000 of images. They call car, 70 car image. Then I don't know, I have it here. This is the unit. Then you have 70 car images. If I go back, I'll have it here. I don't know where it's not coming. Perhaps something. Okay, I forget to validate that I typed 70. Okay, then if I go back, you can see 70 image. And the description, this is a handwriting digits with 10 digits per classes. Then I can have hand, Sudoku, and Python digit and gist classes. Okay, if I validate it, okay, then I have the authors provided like that, around 4 data sets, but I'm going to stop here, given that we don't have enough time. Now, you can, okay, I'm going to create a second data set to show something to you. The second data set is, let's say, 2 data set. Now, I'm going to select the symbolic data set. Then I'm going to provide the name. This is EMNEST. Then I'm going to provide this abbreviation of something extended. Okay, then I have the license, I have the description, the number of image. Then the description here, for example, is, it doesn't provide the number of image with the number of classes, and it says that this is capitalized and lowercase letters. Okay, now I can use ORKG to compare several elements directly here. I can create my comparison here. If I click here, if I click here, I can see that I have, sorry, if I click on the drop-down button here, I can see that I can compare this data set with this data set. I can create a comparison of these 2 data sets directly from here. And then I can click to compare contribution, start comparison, and it will provide me with the comparison of these elements. But another thing that I can use is I can directly search for, go back to my comparison here, NESI main concepts. I'm going to copy the title of this paper. Need some time to come. Then you can see here that ORKG automatically save your contributions when you create it. And in addition, you can, as I said before, if you edit, you can come back and add more properties. The main advantage is that many researchers are going to share the same properties when they are comparing their papers, and they are going to give the same, and they are going to have the same view of the work. Then, if I want to add the contribution that I just created here, I'm going to fetch live data. And then I'm going to add contribution. And then I'm going to add the paper there. And I found here main concepts of, if I click, then my new paper is there. Then any author can document their own paper and add in this comparison. And once the paper is added, you can now publish it. Or you can select your properties. For example, perhaps you don't want all these properties, then you can just come here and select the properties that you want to have in your comparison. Then another thing that is very important for this NESI paper benchmark is that you can download the NESI paper benchmark and analyze it further. For example, if you think that if you have, let's say, 200 papers there, then you can download it in CSV format and analyze it. For example, if you come here, you can click on export the CSV, and you can open your CSV, and you will see the 2 papers there, and you will have all these papers aligned there, and you can analyze it with any tools that you want. You have the title, the AI paradigm, etc., etc. Okay, then what else? Okay, then I added this paper and I can publish it if I want. Then I have the neural symbolic, etc. Then okay, then I can save it as a draft and come back later, and I can add that okay, new version of basic main concept. Okay, then the final thing that I want to show here is that once you organize your research, you can see you can see it has a graph. Let's see. You can have a graph view of your paper. It's loading. And this is the first contribution that I presented. And you can view anything that you want to view. For example, have search problem, AI paradigm, etc., etc. Then this is the end of my presentation on neural symbolic. If you have any question, if you have to join and contribute to this template, please just email me. You can email me. This is my email address. I am also on Twitter. My Twitter is Joe Fidelius. You can write to me and tell me what you think about this work. If you want to contribute, if you want to, thank you very much for your attention. Thank you. If you have any question, you can also ask.
Please feel free to ask the question if you have any query. You can write in the Q&A box and you can ask. So there are no more questions. Okay. So there will be a feedback form to fill by the audience. So please, we request you to fill the form after the session about the feedback of this master class. Okay.
There is a question.
Yes, please. Please scan this QR code and answer the questions of about the feedback, please.
So should I answer the question from the chat? Maybe that's nice, right?
Yes,
Just
exactly.
by talking. So the question is if there's any pushback from academic institutions about using knowledge graphs and how we responded. I mean, as a technology, I don't think there is really a pushback, but mostly I think the main issue is that people are not aware of knowledge graphs, and it's a very abstract concept for them. So what we're trying to do in the interface is trying to make it as simple as possible to interact with the graph without really using the graph terminology. So we're trying to avoid terms as RDF and statements and try to really think of it as that, okay, you provide a value and you have a property to connect to that value. So try to make it a bit easier to understand this way. But of course, it's quite difficult because in the end, a graph is being created and using some terminology is, we cannot avoid that. And that means that people need some training to in the end, contribute to the graph. But I think like, I wouldn't call it pushback. so to say. So I would say it's like some steps we have to take. Yeah, exactly. So the terminology, this is also a discussion within the team, right? So terms as we know them. So I'm a computer scientist. Things that seem very logical to me are already hard to understand by others. So we are even considering sometimes to use different terminology for different domains. So in biology, they often talk about taxonomies and partonomies and so on. And we might want to use those terms to describe an ontology and describe a graph. And for other domains, we use other terms. But maybe I think the easiest is really to check out the ORKG website and maybe see also a bit of the terms we use there. But it includes the term property instead of using predicates, which is a common term in a graph. We don't use terms subject and object, but we just consider it as data to connect something to. We don't use the word literal, but we call it text, just as a few examples there.
I can complete. For example, in my work on food information engineering, I'm saying that I'm providing properties, common properties for comparing research. Then given that in many works, people are already using some properties to compare their research, it's more easy for them to understand it. Okay.
So there are no more questions, right? So we can close it now. Thank you so much, all the audience, for us making this interactive session. Policy, the written star contacts. Okay, thank you. Thank you, Dan.
Thank you, everybody. Bye-bye.
Thank you. Bye bye.
Thank you.